Welcome to AIT Tech Talk, Advanced Robotics from Laboratories to Real Application. I'm Jennifer from AIT Entrepreneurship Center, your host for today. We welcome you all to our second event of the new initiative called the AIT Tech Talks. This series of events are being organized under the AIT Enterprises Alliance platform to highlight the expertise of AIT in various emerging technologies and developments. Today, we will hear from experts in AIT and the industry, and also to interact with some of the best AIT researchers. AIT has contributed to the field of robotics, automation, and industrial advancement through research, education, and working with enterprises and industry partners, supporting their path of industrial competitiveness and innovation. Once again, welcome everyone online. Without further delay, let me invite Dr. Naveed Anwar, our Vice President for Knowledge Transfer, for his opening remarks. Dr. Naveed, please, sir.
Thank you, Jennifer, and good morning, everyone. As Jennifer has mentioned, this is an initiative from the Asian Institute of Technology, and I'm sure most of you are familiar that AIT is a postgraduate institute with a focus on academics and research. Although the main focus of the university is to provide high quality graduate education, master's and PhD, but at the same time, there's a considerable amount of research being done through these researchers and also our faculty and other team that we have at AIT. So in this process, a considerable amount of knowledge is created, as you can imagine, when we have hundreds of people working on their dissertations and their research. And this knowledge is of practical application and value to the society and to the industry. So AIT has a considerable focus on how we can transfer this knowledge to the industry and also learn from the industry so that our research and our work can be more relevant for the region. And this the establishment of the AIT Enterprises Alliance is one of the initiatives that we have in which we formally engage with the enterprises and with the industry and with other partners to jointly explore the knowledge transfer from both directions and also development, co-development and co-creation of high impact projects and products. And as everybody knows right now that robotics, AI, and these areas are very critical to the industrial development of any country. And AIT has been focusing on these things for a very long time. As Jennifer mentioned, our previous tech talk was regarding AI and data analytics. The first one, the second one now, we are focusing on robotics and its application. And if you look at the logo of the event, you can see that
Dr. Naveed. Hello, sir.
Maybe he is having some issue.
Yeah, let's wait for a moment.
Is there any opportunity for the participant to ask question?
Definitely. You can actually start typing on the chat box. And later on also, we can, after the speaker's presentation, you can raise your hand and then ask question, or you can just type on the chat box.
Sir has joined, I guess, Dr. Naveed, sir.
Yes.
Hi, sir.
So
we
sorry,
lost you for a minute.
Yeah, I don't know when you could not hear me, but anyway, so I was just saying that this event and such events that we organize at AIT are very critical for us in both ways. First of all, to be able to share the research and the knowledge that we create at AIT with the society, and also learn from the industry so that we can do some relevant work. And so this particular event today, we are very fortunate that we have speakers both from AIT. Professor Monukit is our lead researcher and lead faculty member on robotics and many industrial engineering areas. And we are very fortunate that he will be sharing his experience and his expertise with us. And we are also very fortunate that we have the president of the Thai Robotics Society, Professor Vidya, with us. And so this whole idea of collaborating with industry and with other academic institutions is what the AIT would like to do in all of its work. And also we are fortunate to have a very eminent speaker from Japan, Professor Wang later, and also from industry, Kunmati. So I think the lineup of our speakers speaks of our AIT's focus on developing collaborations both within the academia and with the industry. And I do hope that all of everyone attending this, joining us, will find this and this discussion useful on the particular theme and the topic, but also an opportunity to develop collaborations and interaction between themselves through AIT as a platform and also with AIT. In the afternoon, as Jennifer mentioned, some of our researchers, students, and our faculty will be showing some of the work. Actually, originally we planned this to be a hybrid event so that some of you could join us in this live visit to our labs, but unfortunately that has not been possible. So it will be now mostly online. And as soon as we are back into full in-person contact, we will invite you to visit AIT. Please feel free to contact us for any questions that you might have, anything that we can assist you with, any idea that you have that we can take on. This event is being co-sponsored or co-hosted by AIT Enterprises, AIT Entrepreneurship Center, and that's where we join hands with students and industry to create new ideas and innovations. So with that, I think I would like to welcome once again all the participants, and I would like to thank our speakers, our collaborators, and our team who has put this event together. And we will be doing this event every 2 months. So we hope that you will be able to join most of these events and participate as well as contribute. So thank you once again, everyone, and look forward to a very, very interesting discussion today. Jennifer.
Thank you very much, Dr. Naveed. And as Dr. Naveed mentioned, for any questions or inquiry about AIT Enterprises Alliance, you can reach out to us at eeo@ait.ac.th. Now let's move on to learn on self-driving cars with Professor Manukit Parnichakun from AIT. Professor Manukit is the head of Industrial Systems Department at School of Engineering and Technology and have spearheading many researches collaboration with industry. Professor Manukit has worked on several projects as the principal investigator, such as development of laser-guided vehicle sponsored by Planet TNS, multiple robot cooperation project sponsored by HGSC, development of autonomous mobile robotic chair with ability of staircase climbing for handicapped and elderly people project sponsored by Health Systems Research Institute and development AIT Library Robot. These are just a few of his many projects. Welcome, Professor Manukit, sir.
Good morning, and thank you very much for the introduction. May I share the screen?
Sure, sir.
Today, I will give a talk on the topic robotics technology by using a case study on self-driving cars. The topic today will cover from the definition of self-driving car. I will highlight the three most famous self-driving car technology from Google. It's called as Waymo, Autopilot from Tesla, Open Pilot from Comma AI. And then I will come back to Thailand. I will explain about the self-driving car development in Thailand, especially at AIT. And then I will pick some of the important technologies and explain in detail about the adaptive cruise control, waypoint tracking, obstacle avoidance, traffic sign detection before coming for the conclusion. Okay. So what is self-driving car? it is a car or the vehicle which can run by itself. The passenger just provide the destination, and then the self-driving car, it will perform two actions. Firstly, it will conduct the global path planning, and secondly, it will conduct local path planning. In global path planning, it depends whether the driver or the passenger want to get the path with the shortest time distance path, or if he select the shortest distance path, or if the driver prefer the cheapest distance path. Based on different optimizing algorithm, like maybe A-star or branch and bound genetic algorithm, particle swarm optimization, or several other optimization techniques, the output from the global path planning, it will be the waypoints. These are the points that self-driving car has to track and follow in order to move from the starting point to the destination. So this is the first part, that is global path planning. And then come for the second task, which is on local path planning. It involves with three major actions, including waypoint tracking, how to track, follow the waypoint, similar to Pac-Man, eating point in a game. Or then the other action, it will be obstacle avoidance, depending whether the other vehicle, okay, they are in the same direction or they are in opposite direction. So if the other vehicle, they are in the same direction, the self-driving car has to detect the speed of the preceding vehicle and check whether the preceding vehicle run too slow or not. If it is, it has to take over. But if it is not too slow, then it just follow. Or if the other vehicle, it come in opposite direction, then the self-driving car has to make decision whether it has to stop in order that the other vehicle can come for a very narrow road, for instance. And the other important action is about the traffic sign or traffic light detection. The self-driving car has to obey traffic sign, like if it is no enter, it has to select the other path. Or if it see traffic light, the red light, the green light, the yellow light, it has to perform a proper action. So these are the two layers of the global path planning and local path planning that all the self-driving car has to be able to handle. There are three most famous self-driving car technologies that I will introduce to you. The first one is from Google. Google launched a project called as Google X project since 2005, and it was led by Sebastian Thrun. Actually, he was the leader of the Stanley team from Stanford University, because Stanley team is the team which win the competition from DARPA Grand Challenge and get $2 million. So after the competition, Google headhunt him and create Google X project. So at the beginning, Google started the project by using a hybrid car. At that time, they have only Toyota Prius, which can run by using either gasoline engine or by using electrical motor. So there exists only Toyota Prius at that time that has hybrid technology. But nowadays, there are a lot of car manufacturers, and it is not only hybrid, it will be fully electrical vehicle. And after a lot of development, in year 2014, self-driving car from Google changed the platform. It is a very uniquely designed platform, and it changed the name of the project from Google X to the Waymo project. So if you have a look on the photos at the bottom of my slide, you can see the photo of Stanley, which win the DARPA Grand Challenge. And the second photo, it is a Toyota Prius self-driving car from Google X project. And the one on the right side, it is Waymo, which is the latest version. Why Google car has the highest technologies? Because it uses a lot of very good sensor and very expensive, of course. So one of the sensor is the 3D lens scanner. For example, if you use 3D laser lens scanner from Velodyne, one unit is the cost or the price of one Tesla. So you can see the price of Google car that it is very expensive. But the good point is that based on 3D laser scanner, it gets the point cloud of the obstacle in 3D and in real time. So in order to navigate the self-driving car, it is very easy because this information is so important in navigation. But in above that, there are also several other sensors like camera, mainly used for traffic sign or traffic light detection, GPS, compass, and digital map. They are used for waypoint tracking. Wheel encoders, they are used for date reckoning system. And during the bad weather condition, Google car use radar in order to detect the environment on the raining day or on the foggy day. The photo at the bottom show several versions of the Google car and Waymo. I have here a video that shows the Google car, and this is the latest version. This project is called as Waymo. You can see that it is uniquely designed. On top, you can see something rotating. That is the mirror from laser lens scanner. It can detect to the distance of around 80 meters in real time, and it is in 3D. So you can see the black part on the front panel. It consists of camera and also radar. So the self-driving car will use all the information, and then it will decide the path. Okay. The second system is autopilot from Tesla. Even though autopilot of Tesla is not the most high technology, but in terms of the commercialization, it is the most successful. And why? The reason is because Tesla used very cheap sensor. Tesla installed a lot of sensors, but all of them are very cheap. They use 12 sonar sensor. They use 8 camera. They use only 1 radar. And in order to navigate, they use AI rule-based in order to navigate and conducting obstacle avoidance. And there are some predefined rules. For example, following the preceding vehicle or lane centering, or the rule which is used for automatic parking system, or the rule when the vehicle has to have a very sharp curvature. So during that condition, it will follow the predefined rule. And this figure shows the sensor installation in autopilot of Tesla. There are 12 sonar, and they are installed 3 sonar for each side, because we know that for sonar, it can detect the obstacle up to around 8 meters. So this is for short distance detection. It installed 8 cameras. 3 cameras are installed at the front direction. 1 camera is used to detect for short range of 60 meters. 1 camera is used to detect for medium range of 150 meters, and long range can detect up to 250 meters. It has 1 camera installed at the back or at the rear part of the vehicle, which can detect 50 meters. It installed 2 backside camera, which can detect the distance of 100 meters. And on the front side camera, 2 of them can detect the distance of 80 meters. It has also 1 radar for the bad weather condition, which can detect the obstacle to the distance of around 160 meters. So based on all of this information, then Tesla can do self-navigation. Now, the autopilot system are installed at Model X and Model S, and it is an option for Model 3. So this video shows how the autopilot from Tesla works. Actually, Tesla is a luxury electrical vehicle. So it looks just simply electrical vehicle. The driver can select the destination, and then autopilot from Tesla, it will perform 2 actions, as I already explained: global path planning and local path planning. And then it uses a lot of sensors. Like, in order to detect the obstacle, it also applies mainly camera in order to detect the distance and direction of the obstacle. But Tesla still claims that it is still the responsibility of the driver to be conscious, because this is just only the assistive technology. for any accident, Tesla informed that it is the driver responsibility. And the third system that I will explain, it is called as Open Pilot from Comma AI. Now today we can see that the self-driving car can be available as a module, just a module of the self-driving car or autopilot, and it is very cheap. And this is the Open Pilot from Comma AI, and it is open source. The driver who know programming, they can modify the parameters, and then they can make the control fit to their preference. The first version of Open Pilot is called as Eon Development Kit. The cost is just only $600. And the second version is called as Comma 2, which costs around $1,000. So it is like a smartphone. There is one camera and the processor is there, and it can do several functions, including adaptive cruise control function, automate lane centering function, and it can provide warning for forward collision clashing, for lane departure condition. And it applies concept of machine learning. Before the implementation, Comma AI provide the system to the drivers, and based on the information of the image received by the camera and the action act by the driver, it collect this information and then do machine learning using deep learning and reinforcement learning in order to provide a proper action. And Comma AI, it interface with ECU, with the engine, with the brake and power steering by using CAN bus. So if the car has already drive-by-wire system, it is very easy to install Comma AI, because the Open Pilot system, it will take over the command from ECU, so that it will send the command to the steering, to the brake, and to the acceleration. Okay, now let's come back to Thailand. Actually, Thailand, we start the project about the same time of the DAPA Grand Challenge from around 2004, 2005. That time, I was the president of the Thai Robotics Society. And then we know that every university in Thailand, they have different expertise. Like AIT is very good in dynamic control. Chulalongkorn University is very good in mechanism design. King Mongkut North Bangkok is very good in manufacturing or machining. So there are 12 universities which join hands, and we try to create a national project on self-driving car project. And at that time, we proposed 26 million baht project to the government to get the support. But that was the year of 2004, 2005, and all the researchers from 12 universities, we are very young and we don't have much expertise. So finally, the government provide us funding just only for 1 million baht, just only to do feasibility study. So after we distribute to each university received less than 100,000 baht. So we cannot do much thing. Finally, we decide to approach company, private company, in order to support our project, and I will explain later. So this video shows the first experiment on self-driving car based on very limited budget. We use only webcam. Webcam detect the road and especially the road line. By using half transformation, we can determine the position and orientation of the straight line, and based on that position and orientation, we will send the command to the steering wheel in order to make our self-driving car run at the center of the road. But of course, during the first year, in the year 2005, the speed is very, very slow. It is only allowed 1 kilometer or 2 kilometers per hour. This is another experiment on adaptive cruise control system. We still use mainly webcam. Webcam used to detect the size and position of the lead circle of the preceding vehicle. If the preceding vehicle runs further, the size of the lead circle becomes smaller. And if it is closer and closer, then the dimension on the side of the lead circle become bigger. Then we can estimate the distance. We can also determine the position of the preceding vehicle by looking at the center of the lead circle in the image. And based on that position, then we can control our steering wheel in order to follow the preceding vehicle. But this adaptive cruise control can get the speed of around 2 or 3 kilometers per hour. And there is one function which is very important for any self-driving car, that is automatic parking system. So if we are able to get the bird eye view information from the parking lot, the planning the path for automatic parking is very easy if we know that bird eye view information. But nowadays, there is no, or there may be very few parking lots which provide bird eye view information to the driver or to the car. So what we can do is just to install a local sensor. It can be sonar, it can be radar, it can be camera, or it can be laser scanner. So based on the local information, we get only partial information of the parking lot. We have to accumulate the information. And after the accumulation by using sensor fusion, then we have to decide how to do a proper automatic parking. So this figure shows GUI of the system. In AAT, we use laser scanner to scan the parking lot. We get the profile of the parking lot, and based on the position of the vehicle, then we can plan path in order that we can do a proper automatic parking system. If we want to control self-driving car, mainly we have to control two parameters, that is the speed and also the heading or the steering angle. So this is the experiment on adaptive cruise control. So in adaptive cruise control system, if the preceding vehicle runs at the speed faster than our set speed, for example, if we set our speed at 100 km per hour, if the preceding vehicle runs faster than 100 km per hour, then we can still keep our speed control. We can keep our speed of 100 km per hour. But if the preceding vehicle runs slower than our set speed of 100 km per hour, we cannot use speed control. Otherwise, we will crash the preceding vehicle. So what we need to do is to use the distance control. And for the distance control, there are several algorithms. Some may prefer to use or keep a fixed distance, like we may set 10 meters, 20 meters. Okay, that is one technique. Another technique is by maintaining a time headway. For example, if we set time headway of 1 second, it means that if the preceding vehicle runs at 36 km per hour, the safety distance, it should be 10 meters. But if the preceding vehicle runs at 72 km per hour, then the safety distance, it should be 20 meters. But if the preceding vehicle runs slower and slower, we may set the minimum safety distance. It depends on the developer, whether we will set at 3 meters or 5 meters as the safety distance, so that we have enough distance with the preceding vehicle. So this is the experiment from Bangkok Racing Circuit in Bangkok that we conduct the experiment on adaptive cruise control. And this is another experiment on fully autonomous. As I already explained, because we get very small amount of funding from the government, then we approach Seagate Technology Thailand and discuss with them and see better how the private company can support the development of the self-driving car technology in Thailand. Finally, we end up the discussion with organizing Thailand Intelligent Vehicle Challenge. We organized it for 3 years, year 2007, 2008, and 2009. In 2007, the theme of the competition just to track, follow the waypoint, but that's already tough at that time because we just start the project. So most of the team cannot run more than 100 meters for the first year. And in the second year, we focus on traffic sign, traffic light recognition. So we have several traffic sign and traffic light, and the self-driving car has to obey. If it obeys properly, then the bonus point will be given. And this is the video of the third year in year 2009. Now, in 2009, we changed the theme to the speed racing. So this is the video from the final round between team from AAT. This is Mitsubishi from AAT. And another team, you can see the yellow car from Royal Thai Air Force Academy. In the third year, the rule of the game is that we will place one vehicle at the 0 kilometer point. Another vehicle is at the middle of the 1 lap distance, because 1 lap at Bangkok Racing Circuit is 2.2 kilometer. So another team is placed at 1.1 kilometer. Then we provide 20 minutes, and the competitor, they have to run as fast as possible, but we limit to the maximum speed of 45 kilometers per hour, because otherwise it will be too dangerous and we will not be able to control it. So the maximum speed is 45 kilometers per hour. Each team has to run as fast as possible in order to catch another team. So if you are caught by the distance less than 10 meters, then you will be the loser. Then we find the next pair until the final round. So this is the video from the final round. Here, the team from AIT, we get the first prize. And actually, our speaker, Khun Methi, is also the team member here. So we install GPS, we install compass, and based on the waypoint, it will try to follow the waypoint. We install laser scanner in order to detect the obstacle. You can see in the racing field, there are several obstacles. And if the vehicle can avoid clashing with the obstacle, we provide 100-meter bonus point. So based on this competition, we could catch all the remaining team in the competition, except that in the final round that we could not catch the team from Royal Thai Air Force, because they are also very fast. But based on after the time of 20 minutes, we calculate from the accumulated distance plus the bonus point, and finally the team from AIT get the maximum distance and get the first prize of the competition. After we organize it for 3 years, AIT organized it on behalf of the Thai Robotics Society. We found that we can make the competition more challenging by using the same rule. It is a self-driving vehicle rule, but now we change the platform from 4-wheel, which is stable, to just only 2-wheel, and it is a kind of the bicycle wheel. So it is not only trajectory tackling or obstacle avoidance, but now it involves with balancing of the unstable system, because the bicycle has only 2 supporting wheels, so it will fall because there is no driver. Now each team has to think about the control algorithm and the mechanism in order to balance the bicycle. So in this video, we can see this is the champion team from AIT. We organize it, but we also participate in the competition. We use 2 flywheels. The 2 flywheels run at the same speed, but in the opposite direction. And then we change the axis of the angular momentum or of the flywheel. We design in such a way that they run at the same speed. It means that the summation of angular momentum on the vertical axis is always 0. So there will be no bias torque to move the bicycle to the left or to the right. But we have the summation of the angular momentum, rate of change of angular momentum along front and back position will create torque to balance the bicycle. Like if the summation of angular momentum to the front direction, then it means that the bicycle, it will have a torque which turn it to the left. But if it is to the back position, to the back direction, then there will be torque to make the bicycle turn to the right. Okay. This is another technique which apply concept of centrifugal force in order to balance the bicycle. Here, if the bicycle is falling to the left, then we can increase the centrifugal force by reduce the curvature radius and increase the speed. Then the centrifugal force, which will be the same as the centrifugal force from the friction of the tire, it will create a moment in such a way that it will flip the bicycle to the right direction. So by control a proper speed and the curvature radius, then we'll be able to balance the bicycle. This technique is very good, very interesting. But anyway, we could, this team cannot get the first prize. It is just only the excellent technique award. And how's about the indoor environment? If we have to work in the indoor environment, And if we want to make a self-driving vehicle like forklift, now the problem comes from the sensor, because we don't have GPS to provide the coordinate X and Y to our system. Then we have to think about other technique in order to localize the system. We have to know X and Y coordinate of the forklift. We have to know the heading of the forklift. There are several techniques which can be used for localization, like we can use data reckoning system using encoder. We can use camera and use visual SLAM in order to identify X and Y and heading. Or we can use laser scanner and use laser SLAM in order to identify X and Y and heading. And this is a technique that we use. We join hand with Planet TNS and create this as a product. We sell with the cost of only 1.5 million baht. Okay, and in the first phase, but in the second phase, we make even as a module so that we can install at any second-hand forklift so that it becomes self-driving forklift. And the technique for localization, we use the combination of laser scanner and the reflector. If we know in advance the coordinate of the reflector, then we'll be able to identify our coordinate X, Y, and heading. This is another experiment on obstacle avoidance. Actually, for obstacle avoidance, there are several algorithms. You can use the most well-known AI rule-based. We can use another famous technique of behavior-based, or we can use the technique of the potential field technique in order to avoid with clashing with the obstacle. Or we can use the combination of several techniques, like the combination between rule-based and also potential field in order to avoid clashing with the obstacle. So this is the experiment, but mostly nowadays in the factory for the self-driving forklift, when it sees the obstacle, it just stops. But we can even increase or enhance the function so that it can avoid clashing the obstacle, so that the time, the working time can be shortened. And this is also a technique which is very important. That is the technique on traffic sign or traffic light detection. Because when we run the self-driving car, it has to obey traffic sign or traffic light. And we use camera, and based on the image from the camera, we have to process it. We remove some noise using Gaussian blur or using any other filtering technique. Then we use edge detection. Based on edge detection, we identify either circle or rectangle. And then we use perspective transformation so that traffic sign is in a proper angle, roll of 0 degree, pitch of 0 degree, and yaw of 0 degree. And then we do normalization so that we get a proper dimension of traffic sign or traffic light. And then we do template matching. Okay, we can use correlation, we can use multi-layer perceptron, we can use Hamming network or competitive network in order to identify traffic sign or traffic light. So these are some of the development in Thailand. All right, now let me come to explain about AIT self-driving car. We developed it on a platform of Mitsubishi Galant 2000cc model 1993, and it has the automatic transmission system. Actually, the cost of our platform is very cheap compared with the cost of the sensor. Like laser scanner is 200,000 baht, GPS is 200,000 baht, but our Mitsubishi, second-hand Mitsubishi is just only 50,000 baht. So it is super cheap compared with the other device. And we modify the system. We install the navigation module. We have GPS, we have compass along with digital map. For the LiDAR module, we use laser scanner to detect the distance to the obstacle. It is used for obstacle avoidance. We install machine vision in order to recognize traffic sign or traffic light. All the information are processed by the processor, and the output, it will be the speed control and the steering control. And because the speed of the vehicle involved with two things, because we are still using gasoline engine, now it involved with the throttle valve of gasoline engine. And also, if we need very high deceleration rate, we need to involve with the brake system for speed control. And for the steering control or heading control, we control the steering wheel angle. This photo shows how we create a drive-by-wire system, because our second-hand Mitsubishi Galant, it is driven by cable, steel cable. It is not driven by signal. So we modify so that it becomes drive-by-wire. We cut the steel cable, we connect the spring with the axle pedal, and then we detect the pushing angle by using potentiometer. And the signal is used is provided to the processor. And then we have a command used to control the throttle valve angle. We install motor with encoder and do position control for the throttle valve angle. And it can also work for the automatic mode in addition to the manual mode. By automatic mode, based on the command from the processor, then we will maintain the speed by controlling the throttle valve angle. And this is the photo of the installation. So we placed the servo motor at the throttle valve. And this photo is the modification of the brake system. For the brake system, we install a DC motor with the steel cable and pulley in order to push, and we use force control. For the brake control, it is not position control, it is force control in order to control, in order to have enough force brake to the vehicle. And this photo shows how we modify the steering wheel. We install an AC motor, 750 watts, and the power transmission system, we select timing belt and also pulley because it has very less clearance, less backlash in the system. And this is the photo of the waypoint tracking system. We select GPS from Novatel. The receiver is in a box, and the antenna is placed at the front shield window, at the front shield glass. It is above the camera, which is used to detect traffic sign or traffic light. And how to do waypoint tracking. For any vehicle, car, bicycle, drone, or boat, if we want to have self-driving function, what we need to do is to create a virtual straight line connecting between waypoint, and then we identify the distance error, which is denoted by D. This is the distance of our vehicle from the straight line connecting in between two waypoints. And also we have to determine the angle of the straight line connect between two waypoints. And we measure our heading angle from compass. And based on the difference, we call this parameter as the heading error. It is denoted by A parameters here. So the job of the control engineer is to design the control algorithm in order to make D and A parameters becoming zero at the same time. We may use state space, we may use LQR, you may use fuzzy, or we may use the combination of two loops of PID. Actually, PD is quite enough. One PD is used to control the distance. We have KP and KD for the distance. We have one PD for the heading angle. We have KP and KD for the heading angle. And it depends on the important, whether if we think that the distance error is more important, then we just provide more gains for the distance. Then the vehicle, it will come very fast to the center, but the heading will oscillate. But if we think that the heading error is more important, we provide more gains for the heading error. Then the vehicle will run in parallel with the straight line, and then it will slowly and smoothly move to the center of the straight line, which connect between waypoint. And this is a technique for any vehicle for trajectory tracking. This is the result from the experiment. You can see that the waypoint, it is shown by red circle, and the actual coordinate of the vehicle, it is shown by the blue cross. You can see that the error is quite small, but of course it can be better if we change the control algorithm or change the parameters. And how's about obstacle avoidance? Mainly in AAT, we use laser scanner. This laser scanner can detect up to the distance of 80 meters. The resolution can be selected whether we want 0.1 degree or we want 0.5 degree. And the accuracy of the distance is around 1 centimeter, which is very, very precise. And here about the algorithm, we can select to use the rule-based, which is the most conventional AI technique. But in rule-based, you have to design all the rules in order to handle all the conditions of the system. And based on the condition that match, then what should be the action? The action will be the speed and also the steering angle. So that is the simplest AI rule-based technique. Another technique is by using behavior-based. In behavior-based, we have the rule for each sensor, and we have the action for each sensor. Okay, if we have several sensors, we will have several rules. And based on the measurement from the sensor, not only one rule will be executed, but several rules will be executed at the same time. But we have to combine the result from all the rules, how to decide the final speed and also the final heading angle of the vehicle. So that is the concept of using behavior-based. We can also apply concept of potential field. We just create a virtual equation in such the way that the starting point has a very high potential field, the destination has very low potential field, the obstacle has very high potential field, or the road boundary is designed to have very high potential field. Then when we navigate the system, we consider the vehicle like a steel ball, and when we drop it in the potential field, which has different height, it will move from very high location. Finally, it will go to the lowest position, and that is the minimum point or the localized position, which is the destination. Based on the potential field we have, then we find the gradient. Actually, gradient, it is just the slope, but slope in several dimensions of the vector. Based on the gradient, we use steepest descent, which is negative of the gradient. We have the magnitude and we have the direction. Magnitude will show the speed and direction will show the command to the steering angle. Subset of potential field, we can use concept of virtual force by assuming that we have the attractive force to the destination. We have repulsive force from the obstacle or from the road boundary. And by using summation of the virtual force, and the force can be spring and damper force, we can control the dynamic of the system. The resultant force in this figure, it is shown by the blue vector. We have the dimension and also the direction, which will control the speed and also orientation. And for the trend of the research and development in self-driving car, in the past, we use a proper image processing in order to identify the feature and recognize the environment. And we have AI rule-based in order to design a proper action for each condition or each situation. But nowadays, currently, there are also the technique using concept of completely machine learning. So instead of using image processing, we just use the raw data from the image and then use deep learning in order to identify the situation or the condition. And for the control, we can also apply concept of reinforcement learning in order to get the direction command and also the speed command directly by using concept of training or learning. So this is a concept of command AI. So based on the image that the driver see from the camera and the action of the driver. So these are provided to the network. And finally, the network will provide a proper action based on different conditions. Okay, now I come for the conclusion of my talk. Self-driving car technology, it is very useful because it makes the driving become more safe and higher efficiency. And I'm sure that it will be utilized practically, and nowadays actually it is already used, even though mostly it is only partial, it is still not fully autonomous. And the authority of several countries, all the countries, they have to understand the technique, they have to be aware of this technology so that they can create a proper laws and regulation and also provide a proper promotion package for the self-driving car technology to make it become through faster. And the indicator that show that the self-driving car is successful or not, it depends whether it is used at public road or not. If it is still private road, like in the golf course or in the village only, it is still not successful. But if we are able to use it in public road, then that is the indicator that show that this self-driving car technology, it is mature enough. And the laws and the regulation, it has to be modified to accommodate this technology, including the legislation of self-driving car, or it can be the testing, the standard, the procedure, and also the procedure during the insurance, the liability and responsibility. So these are the laws that has to be implemented so that we can have the full function of self-driving function. Okay, thank you very much.
Thank you so much, Professor Manukid, for a highly insightful presentation. Sir, there's a question in the chat box.
Please unmute. Jennifer, you mute.
Maybe my speaker, my mic is low. Okay. Thank you, Professor Manukid, for a very highly insightful presentation. There's a question in the chat box, sir. Can I read it for you?
Yeah, please.
This is from Mr. Jamie O'Reilly. Do you think it will be possible to use self-driving vehicles in Thailand? If so, how long? Local customs might confuse algorithms trained on data from other countries.
Okay, thank you very much for the question. For the partial function like assistive function, now Thailand allow the self-driving technology already, like adaptive cruise control or even lane centering system. It is already available in Thailand, but because all the things here, it is considered as the assistive technology, all the responsibility still rely on the driver. But for the fully autonomous self-driving function, so it may take more time, like you may heard about the news a few days ago. Tesla self-driving function, SDF, because Tesla, it has autopilot, but that is still assistive technology. It planned to launch fully autonomous so that the driver doesn't need to be at the driver's seat at all, actually. But because the technology still has some bug, so it make the two passenger pass away from the accident a few days ago. So they have to handle all of this bug, and they have to have enough data and proper testing before it will be launched. So I think it takes more than 5 years for fully autonomous. But in any case, the law for accommodation is the obstacle. So the technology must be mature enough and prove that it is very safe. In that case, then the country will allow in Thailand. I think more than 5 years for self-driving function without driver at all. But if we make a designed area like the road, we have like bus lane. So if it is bus lane, taxi lane, then it can be implemented even faster because we have to install infrastructure. We have to prepare proper infrastructure for self-driving function. Then it will be faster if we invest on the infrastructure. Otherwise, it takes more than 5 years for fully autonomous. Yes.
Sir, there's another question. Do you think the city structure and design will have changes while the self-driving technology is implemented in our society?
The size, can you repeat the question?
Yes, sir.
Traffic size or what?
Do you think the city structure and design will have changes while the self-driving technology is implemented in our society?
It may, but I think it is the job of the developer to align with the existing regulation. If it change infrastructure too much, there will be a lot of resistance, and it takes longer time in order for real implementation. But if the developer accommodate or research in such a way that it is in line with the existing infrastructure, then I think that it will be faster be implement.
One more question.
Traffic sign or traffic light will be the same as before, but it is a job of the self-driving car to recognize it. Yes.
Oh, I see. Another question, sir. How will the self-driving car perform on new roads? Does it need to know the environment beforehand?
For the new road, it can perform, but maybe a bit less efficiency because for the new road where we don't know the waypoint, the coordinate latitude and longitude of that road, then in that case, it will rely on the laser scanner and also the camera alone without navigation tracking. So it can perform, but the performance may be less than the regular road where we have all the information about the waypoint. Yes, but it can work. Yes.
Do we have any more questions? Okay, maybe none for now. Moving on, to inform you all, AIT Industrial Systems Engineering has initiated Machine Shop and Prototyping Center. The center is open to serve needs of academic and industries in machine design, development, and prototyping. To learn more, you can connect to us at their website, mspc.ait.ac.th. Now, our next speaker will be presenting at 10 a.m. So we have a few minutes to have a break, a very short break. So let's have a break for 10 minutes, and then we'll see you all again at 10 a.m. Thank you.
Here in AIT, the environment is truly international and multicultural, as people who work, study, and live here come from more than 30 countries across Asia and other continents. That's why I have plenty of chances to make new friends and learn about the cultures. The learning experience here in AIT helps students to achieve their full academic potential. The classes here have become a stage for students from different cultural and knowledge backgrounds to discuss issues that matter globally.
Being here, I was inspired by the Institute's goal of creating innovative solutions. My research focuses on novel green 3R biotechnology that recycles, reduces, and reuses our waste. I am certain that the research findings we are doing here at AIT can potentially be applicable globally to make people's lives and environment better and to achieve sustainable development goals.
Social impact has been AIT's legacy and is still our positioning today. Social impact permeates our research and our education. We're injecting more innovation and multidisciplinary thinking in our research. We're engaging in more collaboration with globally prestigious universities, including dual degree programs. We're making AIT more relevant by broadening and deepening our network of businesses and NGOs and governments for the benefit of research, internship, and job placement. And we're nurturing entrepreneurship and service learning as part of AIT's experiential education.
A distinctive feature of our teaching and research programs is their close alignment with some of the major global challenges facing humanity. For example, climate change, energy, food, water security, technology, public policy mismatch, and human-machine fusion. Now, given the innate complexity of these challenges that defy straightforward explanations, our teaching and research programs emphasize multidisciplinarity, cross-thematic considerations, and pragmatic insights into the role of emerging technologies in broader socio-economic contexts.
We are working with many universities and governmental organizations in research collaboration and outreach activities. Some of our research findings have already been translated into new government regulations, new engineering standards and practice, and new engineering applications and tools. And I believe our long-term effort has created significant social and economic impact for communities in the region.
We believe that our main role is to produce experts who are truly global citizens who can think globally and act locally. Our School of Environment, Resource and Development takes an interdisciplinary approach to study, analyze and solve global and regional sustainable development challenges, such as social and gender inequalities, rights and sustainability, urbanization and migration, food security, energy and environment, natural resources, and climate change.
The best management schools in the world are based on a strong industry involvement with leaders coming from around the world. It's also a place where a culture of innovation is encouraged. At our School of Management, that is the culture we're trying to encourage, with regular interaction with organizations and business schools where teaching staff and faculty come from around the world. No idea is discarded, and a multidisciplinary approach where collaboration with other schools is supported.
The Entrepreneurship Center is supporting AIT students, its faculty and alumni to transform their ideas into tangible outcomes such as prototypes, business plans and startup companies. We aim to bring our experienced AIT alumni and successful entrepreneurs back to the campus to share their experience and stories and to work with our students and faculty to build their dreams here at AIT.
It's not only the knowledge and subject in the classroom, but the way of thinking. Because when we come to work, it's not exactly as it happened in the books. So having AIT experience, so we look at this like a way of life, and I can find many solutions to overcome the obstacle, the problem. And also another thing is initiation. This is the very important thing for the success in the working life.
In my personal career, with the knowledge that I have gained from the Asian Institute of Technology, it has been very helpful in dealing with people, in managing my work life, in managing my family life, and also in actually furthering my knowledge through the research capacities that I have gained from the Asian Institute of Technology.
Graduates will be well prepared and have vast opportunities to pursue their passion for social impact by continuing in academia worldwide, or joining local or multinational companies, or working for socially focused NGOs, or becoming government officials, or starting their own businesses.
Welcome back, everyone. Now let's move on to our next expert speaker from the industry. His topic is Advanced Robotics Implementation in Factory from Microcontroller to Machine Learning. Mr. Methi Srisupandit, an AIT alumnus, is Senior Department Manager at Siam Kubota, who has been leading projects related to automation and robotics at Siam Kubota, which is one of the leading enterprises in agricultural innovation. Let us all welcome Kun Methi. Please, sir.
Thank you, Jennifer. Good morning, everyone. I have listened. Actually, I'm so excited to attend this, and also have a little worried about the preparation, because actually I'm graduated 12 years ago, and I'm quite scared that my expertise or knowledge is not maybe enough to sharing to everyone, because I'm going back from academics to working in the business. But after listening to Dr. Manukit's session, that actually most of the stories was also happened during my time in the academic. So everything happened 12 years ago about the like self-driving cars, the AI, the machine learnings, and also everything about this autonomous vehicles, which is I'm surprised that we learn many things, we invent many things 12 years ago, and no one noticed that. But when the trends come, when everyone aware and have an awareness about the autonomous vehicle, then like all the knowledge we have can be utilized right now. And I'm so excited to share with everyone that about my stories that happened after graduated from AIT, and how can I implement the knowledge to my companies and also to the country. So let me start with the sharing my screen. So everyone can see my screen, right? Okay.
Yes.
Okay. So let's start with the stories. So because the story is about the implementation of from laboratory to the business or to the industry. So I'm thinking myself that, okay, when I graduated, what happened, what I have done from or utilize the knowledge and the skill from AIT during master degrees to implement in the companies. So I'm thinking about the microcontrollers, and right now we are doing about the machine learnings and AI, which is actually I've learned during the course with Dr. Manuki 12 years ago. So okay, we will start moving a little about the story of myself. First, start is who am I? I'm Methi Srisupandit. I'm a senior IT department manager in Siam Kubota Corporation. Actually, maybe my title was not related to mechatronics or anything, but I'm just moving to the field of the IT and the data analytics just 2 years. In the past, I'm an engineer. And also, sorry, the engineers and the production managers in the factories. I've graduated from mechatronics and Master of Engineering in 2009, the year that we finished. We won the Thailand Intelligent Vehicle Challenge. And because during that time, I got the scholarship from my company. So when I have graduated, I have to go back to work at my company because I have a scholarship from them. And of course, when went back, I have to work as a production engineer. So we design machines, we install machines in the factory. It's not related at all with the knowledge about robotics, about the localization, about self-driving cars, or even when I have graduated, go back to my company, I also present the projects or even this clip that the intelligent vehicle self-driving car to the management. Everyone's surprised about that, but 12 years ago, no one have ever thought about implementing this into the market, or the price or the technology was ready for the country. And of course, as Dr. Manukin mentioned, that the law still prohibit about the implementation of self-driving vehicle in the road. Even right now, they just allow about a couple of years ago. As you can see in Thailand, we just only allowed like the what should I say, the adaptive cruise control just only available in Thailand just a couple of years, maybe less than 5 years, because of the regulation was just allowed. So it's very slow moving technology that we have invented in a very long time. So when we are going back to, I guess most of you also the student right now, or even the alumni or the graduate student, you will also face something like me. Maybe some of you have lucky enough to work with the research company or the innovation company, but I guess some of you also going back to the factory, same as me. So what's the feeling that the first day when you're going back to work at the company or even the factory? Okay, life after AIT. It happened 12 years ago. The first feeling that I have, and okay, maybe this talk was not much technical as other speakers, but I would like to share about the life after master degrees and working in the factory, and how can I change the corporate and the cultures. The first feeling is that I'm an alien, totally alien amongst the other engineers and others employees in the companies. What can I define aliens? There are 4 things that alien has different from us. The first one is languages. Even we study just only 2 years in master degrees, but when we going back, I can feel that my language is totally different. Like for example, in AIT, we speak in English all the times, but we have going back to my company, so everyone speak in Thai. And we have in the factory, because day-to-day work has a very high amount and lots of incidents and issues happen every day. So we have a very few time on research and about the study of the new knowledge. So the language that we use that or the knowledge that we have is totally different. You will feel that, and everyone feel that you are speak or you are knew something that they doesn't know at all, and most of the people will feel that those knowledge is not applicable in the real life work in the factory or even in the production line, something like that. Another thing is that we have learned something was too new for that time. Like for example, the intelligent vehicle. It's just a buzzword in a couple of years, but we have learned it 12 years ago. Or even the AI or the neural network. We have learned neural network 12 years ago already, but it's just a buzzword right now. It's just a very new knowledge right now, but actually the core concept or the core principle just happened a long time ago, and we have learned that, and we have even write the code by ourselves 12 years ago, or even 13, 14 years ago. And the skill set is very different because during the academic periods in AIT, we have to like manufacture, design, and even assemble any board that, as you can see on the document session, all the boards or the equipments were designed by the student, or even the assembled by the students. So every part we have to design by ourselves. We have to know not only the theories or the concept or the formulas or calculation, we also have a skills to assemble, to design, or even the design the wiring of any circuit board that we use in our project. So the skill set is very wide compared to in the factory, which is we split into function and they know very specific view. And also another thing is totally different about the practice we handling tasks. Because during the academics periods, we have to research, and we research a lot. Research in anything that related to our thesis, but based on the factory, based on the day-to-day work, lots of management and regulation, and also the practice that they use with the problem solving, they try to find a solution as fast as possible. And in the academics, we got the solution, we also compare other solution to understand how each solution or each technologies work, which is not practical at all in the business, because if we get something that works, we keep simply utilizing that. So I'm feeling that I'm an alien, even just 2 years of studying. So I can feel and I'm aware that those 2 years in AIT has changed my life and changed the way of thinking, changed the knowledge and the skill sets, and also the practice that I'm handling my life totally new. So as you can see, like for example, for the knowledge, before I attend the class or attend the master degrees, I have no skill about programming, AI or machine learning, but just 2 years, we can make lots of skill available for me, like programming in any languages or the AI machine learning, or even building the robots by ourselves. And also the practice about the search and research. This is the key issues or the key different thing between business and the academics. So if anyone have an experience about you would like to implement the new technology to the corporates or even to the industries, this is the key different thing between practice in the academics and the practice in the business. Because in the academics, we keep search and research a lot. But in business, maybe we just get one solution that works, and we keep repeating that in terms of efficiency and make it productivity. So we concern a lot about the profits and the efficiencies more than just how to find the best thing or the latest technology that available. So after realizing that difference, I'm in the middle of the crossroad, because I have to decide which way I would like to go on my career, like being the general managers. As you can see, lots of people that graduate from even master degrees or the doctoral PhD, maybe someone converted to be the general managers, which is good, but you will focus more on the management style, like to be the team leaders or the management, to focus on the business efficiencies and the alignment of each BUs or the function in the company, practice skill coaching, and try to find the business opportunities. Even though you have the technology background, which is great to help you enable, understand more technology than others, but in the end, you will those knowledge will be less and less values in the business, and you will change to be the general managers, which is important for the company. But based on my experience, most of the people choose this way. And another way that I choose for myself is that to be the tech geek managers. I'm doing something totally different, because I'm from the AIT period, so I have totally changed to the tech guy. having fun with new technologies, keep studying, keep try new things, and not only try by myself, we also implement in the company, implement in the industries, and try to pitch the ideas to the management all the times, and also very obsessed with the problem solving. Even though that problem is very small, but just some annoyance, but we try to solve something to help people to have a new way of working, to have a new technology to improve their working, and having fun with the working with a small team. Because when you are different from others, when you are the tech teams or the geeks in the corporate, maybe very few people understand you and praise for your skill. So your team will be very small. There's just a small people that understand you. And I have tried to collect the diverse style and the skill from lots of people. Like we have some marketing teams, we have someone with that understand how to communicate, or even understand the financial, something like that. So we cooperate a lot to create the new things for the companies. And of course, based on my 2 years of working, and I can see the opportunity, that's okay. If I become the general managers, I will like the others that haven't attended the beautiful course in mechatronics. So I decided to be the tech geek managers. And it's not easy to be someone that is totally different from others, because as you can see, you are an alien. You speak other language. You have very different practice compared to others. You have totally different skill sets, and you try to convince others to try your own ways of working. So I call this the secret innovation. You cannot just explain them or show them or contribute, but you have to like change the cultures and show them how to show another ways of working. So not focusing only the business or the efficiency or the profit, but will also have like encourage others to embrace the innovation, embrace the testing and failure cultures, which is very practical in academics. Because if you look back into your thesis, you fail most of the time. You test some new algorithm, you test some new coding, and it failed. And you learn from that failure, and you try to understand, is this because of the principle? Is this because of your coding? Is this because of your device? And then you test again, you fix it, and then you launch it again, test it again, and fail all the times. Luckily that the trend right now has accepted failure a lot, and the trend of the management and trend of the business of the world have changed from the silos or the efficiency focus to be the innovation focus. So it's a very good time that it's much easier to innovate and to change the culture of any corporate to be more innovative by using the academic practice into the corporates. So how can I secretly innovate my company, especially the engineering and the factory, which is mostly focused on the efficiency and the profits and the costs? First one is that we have to spread the cultures, the academic cultures. How can we spread the academic cultures? The academic cultures that need to be cultivated and also spread into the company. It's about the research. If you imagine the work in the factories, you are the buyers, and you are like invest and buy the machines or the technologies and then install in your production lines. So most of the practice about the technology is that you get the advice from the vendors or the technology sellers to understand more of the technologies and then buy those technologies to install in your company, which is good. But we have to add more about the research and also self-studies. I've encouraged my staff and also my team to develop our own technology instead of pure 100% buying from buyers. Because when we learn something by ourselves, we will understand more in that technology. And most of the times, maybe the vendors or the sellers didn't clearly understand those technologies because the core technology developer was in the research and development section of those companies. So when you implement in your factory, you will face lots of issues, lots of problems, or even the technical problem. So if you have experience and also the knowledge about those technologies specifically, you can implement it very cheap, and you can also fix the problem very fast. So, but at first, before that, you have to understand and you have to research and test the technology by yourself, which is lead to the second culture, which is hypothesis testing. This is very common in the academics field, but when you go to the factory or the business, it's very hard to implement hypothesis testing because you have a very fixed environment and you have to like making products all the time. So you have to set some space, you have to set some schedule or the timeline for those testing and research, and also publish those finding to the company or to the team that okay, we get this hypothesis and we already test and we research on that technology or hypothesis very clearly. And also we have to use the different approach comparison. In the past, most of the factory or the corporate will focus on just single solution that work. But right now, because we have to innovate and we have to embrace failure more, so we have to try out different approach, different technology, and then compare them within our site. We cannot wait other to test because each factory, each corporate has totally different environment or any factors. So most of the solution is very customized. So we have to compare and understand. And like working like academics, as you can see, most of the research was about not only about the new technology, but also about the comparison of the technology itself. So we have to implement those methods and those mindset into the corporate instead of using the previous one, which is mostly focused on the efficiency or the profit. The second one is about to be the leadership. Because you are just the only aliens among the human. So most of the human will scares a lot about the research and about the new things that they didn't know. So based on you are the only alien in the team, you have to be the knowledge pool for the team. But you should not do by yourself. It's like you be the supporter, but you have to secretly explore and research those technology by yourself in advance. And then like let them learn and let them research by yourself. When I have written down this presentation, it's like when I call back my memory when I have doing the thesis on my research with Dr. Manuki. Like most of the professor maybe already know the solution, but they let the student learn and fail by themselves. And when you have some big obstacle or have on the crossroads to decide the solution or the technology you would like to implement your thesis, maybe you consult back to your professor and they just guide them the way. But actually, those professors also research by themselves and also like to get all the information or even test those technology already, but they let the student learn by themselves. So you have to implement those mindset and those practice back to your corporate as well. You need your team to learn by yourself, even you already know the solution. So it's like the third one, like you have one step ahead of the team without the team notice. Most of the technology and solution that myself implement on the factory, I have studied a lot about those solutions and technology already, but I have let the team research and try by themselves. So they get the feeling and the experience. Because the innovation process was not about the products or the solution, but it's about the experience of the team, that they have to experience the research, the learning experience, the trial and the failure experience by themselves. So they will embrace the innovation life cycle. And the last one is they have to keep studying, and also we also have to keep studying and sharing with the team. Like on the past 12 years, I've learned about the neural network 12 years ago, but okay, the technology was not popular during that time. But just like couple 5 or 6 years ago, when the rise of the AI and the deep learning came again, I also had to keep studying and research on the internet by myself a lot. But I have learned that the knowledge that I've learned 12 years ago was helped me a lot to understand the deep learning, the neural network, or even the current technology of AI very fast. So if you keep on studying and researching and keeping up with the trend, which is you need to deeply understand and deeply research about those technologies, will help you a lot about to improve your cultures or even improve your business technologies portfolio. So as you become an alien, not only spreading the cultures or even the academic practice, and you also have to keep researching and keep studying any new technology that available, which is I have heard that AIT start the entrepreneurship center and also the knowledge sharing between the corporate and the other alumni with the staff in the faculty, which is really great. Because when I'm studying new technology, when working in a corporate, I'm very desperately missing my life at the AIT, that I can search any paper freely, because AIT has provided you with lots of access to any papers, the paper website like the ResearchGate or the IEEEs and lots of the publishers. But when you are working in the corporate, you have a very small chance to get access to those newest papers available on the global landscape of technology. So it's very good chance that AIT have a centers that connecting between the corporate that really need new technologies with the faculties member that already have all the skill set and also the technology in their hands. So that's all for the cultures part or the culture transformation. So let's go to the result that about the 12 years that I working in my company, what we have developed, and also the trends right now for the Kubota and also the agriculture landscape that moving forwards with the technology. So I would like to share first about the project that I have worked with my teams, that I have started with one project that implement the robotics automation within the teams, that no one has any knowledge about the robotics and automations. I'm just the only one. Just 2 years after graduate from AIT, and I started this project, and I call it as a leap of faith, because I'm the managers there, and my team just only 5 and 6 people that have some just a bachelor degrees in mechanics, one on the electronics, and one of the technician that have learned about the PLC and the automation, the leader. But I have implement those technology in 6 months, and this is the result. We have created the automated transferring process from the assembly line to other assembly line, which is totally 100% human free. Everything manufactured within factories and assemble, manufactures and designed by our own staff, 100%. In the past, maybe we hire some vendors, we hire some implementers to implement all the technology and provide the solution for us. But in this case, we just buy the device individually, and we design every machine and every mechanism by ourselves. We designed this just only 6 months, and just only 5 to 6 people to assemble and design everything. This is the first machine that we designed, and we used this, I guess, 8 years already. And this machine has a 0 downtime. The single, I guess, is the first machine in the factory that have 0 downtime. So there's no breakdown at all, because during the design process, I have educate my team to learn about the safety factor, about the module calculation, the how can we prevent the accident, how can we prevent about the communication errors, and about the mechanical wiring, about the maintenance period design, lots of things that we have implemented in this project. And why it seems not that difficult for you when you're in the academic view to see that this kind of automation. But when you work in the factory or work in the business, the key difference between academic research or thesis with the implementation in the factory is the robustness. Because as you can see on the presentation, we have to manufacture and we have to do this kind of work around 500 times a day, and it's run 8 hours a day without any stop. So when you're doing research, maybe you just only need one shot to record the video and present in the thesis presentation, or just a couple of shots. But when you are implement those technology, you need robustness of your machines and your automation. So that was a key difference between the academics and also the implementation of those technology. But luckily that during that time in the study in AIT, those autonomous vehicle, we have to show them all the times. Like during that time, the Dr. Marukit also announced and PR a lot about the intelligent vehicle. So we have to like demonstrate how the intelligent vehicle working in real time, couple of times a week, like 2 times or 3 times a week. So we have to improve our vehicles, our programs, and also any mechanical boards and electrical board to be very robust. We have to ensure that when we need to show, it can work perfectly. So I have learned a lot about the robustness of the design and also the programming during that time. So I've implemented those knowledge or those skills back into my factory. And not only these machines, from this just a small machine that we have manufactured, an AGV, that the vehicle that can drive by itself, it's very easy because it tracks the lane or the color lane or the magnetic lane. It's a current viable technology, but if you look at the products that sell today, the price is very high. But when we manufacture and design by ourselves, I can make it cheaper, like 3 times cheaper than the market price with 0 downtime. So no breakdown at all with these machines. So if you have deep knowledge in those technologies, you can implement it with much, much cheaper because you invest a lot of time studying and practice the technology before. So it's very much cheaper. And based on this kind of technology and the skills that we have, we expand more. Not just only this project that we invest just only 1 million baht, saving the investment cost around 6 million baht and reduce the running cost a lot. We can also like start the new age of AGV. Like when we start that project and we announce that project throughout the factory, those other production line very excited about the implementation of the AGV because those AGV was manufactured by ourselves with very cheap cost. So we expand those technology and we sharing those technology to other production teams or other production line, so they can make the AGV by themselves. And just a couple of years, I like 1 to 2 years after the first launch of those AGV projects, we have around 200 AGVs throughout our factory because we expand those technology and those knowledge and the know-how about how to manufacture and design the AGV to all the production members, so they can build and manufacture by themselves with a very cheap cost and help the efficiencies and also the reduce the manpower cost a lot during that time. And we're not stopping with just the AGV. We're also making the robot by ourselves. This is the automatic bonding machines. In the past, we have to use human to do the bonding between the manufactured parts. So we implement those knowledge about the robotics and automation to manufacture this robot by ourselves that can program to make the bonding. Maybe you can see that, okay, lots of manufacturers have sell the robotics arm that can do the bonding process. But we decided to develop by ourselves because we would like to seed or to plant the knowledge into our staff, because this kind of technology and knowledge can expand and can synergize with other knowledge to be more. Like, for example, not only bonding, but we can do like by the torque control or even the tightening process. Maybe the machine is bulky, but because we make it by ourselves 100%, so the downtime is very small, and the fixing cost and the maintenance cost is very small as well. And even this technology, if we invested more and we studied more, we can even change to our new business to making the machines for other factories or even other business as well. So as you can see, we have expanded a lot about the AGV and even make it bigger and bigger. The biggest one is that we can lift like 1 ton capacity with just a single AGV. The cost is just around 100,000 baht, around just only that. We can lift the 1 ton units. Like, for example, this video to show that in the past, we had to use the electric tolling car and 1 human to pass the frame of the combined harvesters to other production line. But then we changed it to use the AGV instead. Like this one. You have to implement the zero turn mechanism with a very cheapest cost and also fully autonomous without any human intervention. And it can work like 24/7 without any downtime. So because we invest in some technology and we keep our team to research, studying, and trial, so the cost will be very small and we can expand to more and more advanced technology. And next one is I guess I have developed this solution 3 years ago on 2018 about the machine learnings. We have issues a lot about the leveling and the sticker posting on the machines that, okay, maybe the operators or the staff have very weak or very tired, so maybe they are missing the models of the labeling on the stickers. So if we use like the industrial technology to like the automatic picking, placing, we have to invest a lot. But we can use the inspection system, which is very cheap. We can use just only the web camera, which is around 2,000 baht in total with only 1 PCs, and write our own machine learning program to detect the label and then cross-check with the database of the manufacturing that, okay, this product was has a correct label or not. And we can show to the operator that's, okay, the label, your stick was correct. It's very cheap solution and very efficient. This is the video of the solution. And if you ask for the current vendors or the vision sensors, as I see right now on the market, as a very few vendors has already implemented the machine learning in their solution. They're just only using the image processing, which is a very high computational powers to compute the image and have a lot of advanced image processing technique to identify the label. But based on the machine learning and the already published package on the internet, you can make it for free of charge, just only few coding knowledge, and also like just only 1 web camera, you can implement this solution anywhere in your factory. So it's very cheap, and it's encourage others to see that the newest technology in the world has not to be expensive. It can be cheap, and it's not secret anymore because the community of the developer embrace the open source trend. And also we have a GitHub, we have the medium that everyone would like to share their solution, share the programming. So the knowledge is not hard to obtain anymore if we keep the culture of researching and studying, we can get any knowledge to implement on our factory or our company all the times. And that aspect was about the factory part. And the last one is about the business part. Because as you can see that Kubota is also in the agricultural sector, and we're looking forward into the future that, okay, we are moving forward to the precision farming or precision agriculture. We not only focus on the machinery anymore, we also focus on the data, we focus on the IoT and synergize and the integration of all the data to make the agriculture more precise and more productive. So in the future, we foresee that right now in the process of the mechanization and also transform to the smart agriculture, which is about the data precision agriculture, not only about the machinery, but also about the data to assist the farmers to understand more about the field and also the practice that they need to get rid of the issues in their farms. So maybe in the past, you perceive that Kubota mostly focus on the machineries. We still focus on machineries anyway. We sell tractors, we sell combine harvester, excavator, diesel engine, power tiller, and also transplanter. But right now, we expand our vision more to be the end-to-end solution. We focus around our farmers to have a better life. So the machinery was just only the one section that helped them get better yields and better profit. But that's not the only factor. If they understand more and if we can help them throughout the supply chain around our farmers, we can improve their life and we can improve their profits. So what kind of technology that we need? In the past, we just implement the machinery solution, but we have to integrate with the agriculture solution. In Kubota, we have to invest more and study more about the agriculture, not only the machinery, not only about the produce the cheaper machine, the more versatile machine, or the more efficient machine, but you also have to learn more how to implement those machines in the field to make them more profit, to make our farmers gain more profit and get better yields and get lower costs. And we call that a Kubota Agri solution, which consists of machinery solution and also the agriculture solution. So in the couple of years, like the 2 or 3 years, Kubota have evolved a lot to expand more our service and our machineries to cover all of the process within the field. And in the future, we expand more about the getting data to our farmer. Like last year, we already start to selling drones, and also we have supplied the farmers in Thailand about the crop calendar application. We have a chlorophyll analysis, and also last year I have also co-researched with AIT to develop the CCTV camera that can analyze and also justify the chlorophyll values of the rice field to get the data to the farmer to understand more about the health of their rice in the field automatically, and also develop the weather solution and also the farm management solution. This year we also start to selling the greenhouse solution to our farmers and expand to the vegetable solution and also the fruit selection solution. So we expand more our portfolio and also the solution to be more precise and get our farmers in Thailand to be more like the precision farmers, not only just a traditional to doing in the traditional way, but doing more smart way by using data to assist them to make their farm more productive. So this is some of the technology that we use and we test within our farm. We have a Kubota farm in Chonburi province that to test this technology by ourselves. Not only the machine technology, but also the field design technologies. Like as you can see on the left side, that the rice field was a curvatures, and those curvatures because we designed that to match with the slope the field to keep the fertilized top layer of the soil to be exactly the same, and design all the width and all the distance to be applicable with any machinery solution. So this is current new goal and vision is that to increase the efficiency of our farmers and to standardize the farm work to be more precise and using the data to reduce the cost of the farmers and reduce and increase their profits. Okay, maybe I have to skip some of the solution. Like right now in Kubota, Japan, we also launched the cases solution, which is the integrated platform from the machines and also the data to provide to the farmers to understand more about the yield and also information in their farm. And also in maybe, and actually we also already sell the autonomous tractors, autonomous combine harvesters, and also autonomous transplanter and drones in Japan already. But those technology was still based on the RTK solution, which is very expensive in terms of device and also the RTK antenna network. So as you can see that even though the commercialized product right now just use a technology which have a very high cost. So we need to implement the lots of research, and we have to research and join force with the academic teams to find the cheaper solution to implement with the farmers or even into our machineries to make it more commercialized and more accessible to our farmers in other countries. And this is the solution that we implement in Thailand. We call the Kubota Intelligent Solution, which is the telematic solution. We install the GPS device and the mobile connectivity device to our machines, the tractors, the combine harvesters, and also the mini excavators. And we gather those information and then publish those information to our farmers so they can see their result, their working out, their working performance, the driving path of their machineries all the time in real times. And we also develop the crop calendars, which is the assistant application that keep track of their rice field and also their farming behaviors. They can record, and we can also suggest the suitable period to doing agriculture tasks through application automatically. So farmer will be more efficient and more productive with their solution. And we are now in the process of research the farm management system that integrates all the AIT sensors into the single platform and then provide to the farmer. But this is just in the research project that we working within ourselves, within our testing fields. And also the scouting drone solution to analyze the field and then get the information to the farmers about their health, about the health of their field based on their crop types. And also the machinery matching platform, which is like Grab and Uber that matching the machinery drivers and also the farmers together to help them accessible to more advanced machinery, and also even provide the rental solution or the rental offer to our farmers. And this is all for me and for the Kubota that we are working right now on trying to implement the newest technology or the research into the industry and to give it to our farmers. And last but not least, about the conclusion of my experience 12 years after I have graduated and also try to push forward the company into the digital era and also the newest technology innovation. First thing to give my everyone is that even though you have already graduated, you already got a degree, but after that you still have to keep practicing and keep studying new skill and your practice in the academic view. It's like the practice that you have to keep researching, keep trial and fail and try again, keep comparing the technology or the newest technology or trend to understand which suitable for your industry, which suitable for your situation. and keep research and testing the new way of business, just not only by yourself, but also into the business itself, to make it everyone sees the new opportunity of your business by utilize the new technology. And the last two things is that you have to believe in yourself, because when you are exploring new technology, no one knows the solution. No one knows the answers. Everyone is new in this field. So you have to believe in yourself that you are doing the good thing. I'm not saying you are doing the right thing, because you will have to face the failure a lot. But you have to believe that you do the good thing for the company, for the country, and for the human being. So if you have to believe in yourself, and you have to keep doing it, because if we just only learn, we got the degrees, it's just only a paper. But if you haven't done anything, haven't implement any knowledge into the industry, into the business, the world cannot move forward, and we cannot move forward into the better future if we don't do anything and just keep our degrees on the wall just as we graduated. And that's all for my presentation, and also is my speech. And thank you everyone to listen throughout this session. Thank you very much. ขอบคุณครับ So
thank you very much, Kun Meti, for sharing your experiences. Indeed, it's not enough to have the knowledge. We should apply the knowledge in order to innovate and make our work more efficient. Thank you so much. Do we have any question for Kun Meti? Oh, we have.
Oh.
Thank you for sharing your experience. What are the safety precautions related to using AGVs in your factory? How do your AGVs implement object avoidance?
Actually, same as the vehicle or the solution that Dr. Manukit mentioned as well, because we working in the factory. So actually, in case of the obstacle, the best solution is that don't avoid it, just stop is enough. And we just use the small sonar sensor, and because of in terms of the implemented technology in the factory, we have to concern a lot about the cost. So we cannot use the LiDAR sensor or any sophisticated sensor to detect any obstacle. We have to install just only the small sonar sensor, about a couple of thousand baht, just only that, and then try to install around the machine to detect just only about the 1 meter perimeter around the AGVs, and then stop and then alert of the nearby staff or even nearby operator that to aware that, okay, the AGV has found an obstacle and they already stopped. And we have also tested one of the solution is that actually also in the presentation as well, but I haven't mentioned, because during the route of the traveling of the ATV, there was always the staff that go passing by all the time. They have walking around the factory all the time. So we implement like the timeout, just very easy solution. Just when they detect some obstacle, they stop and then they wait just for a couple of seconds. If they still be able to detect the obstacle, so they will raise the alarm. And if like within the timeout is, in this case, it's just 10 seconds. If they haven't seen the obstacle, so it keep moving forward. Just a very simple solution, but we have to make it practical and make it cheap to implement in the factory. So last but not least, about the topic about the obstacle avoidance. Maybe in the market or in the research, they have lots of sophisticated solution, but based on your environment, in your industry, in your factory, you have to research and understand more about the optimal solution that weigh between the benefit, the alertness, and the downtime, and also the cost of those solutions to implement in your industries. I guess that's for the question. Yeah.
Kun Meti, there's another question.
Yep.
How to do business transformation using AI machine learning in traditional business lines like farming? How difficult is it to convince all stakeholders?
Yeah. very hard. And I can frankly say that we haven't succeeded yet, but we are on the like
Apologies for a connection lost. Let's wait for a few seconds.
hello.
Hello, Kun Meti.
Okay,
Yes.
okay, I'm back. Actually, it's a blackout in my home. Really surprised that about the implementation of AI is very hard, and how can we do is that I start with just a small project. Maybe I haven't mentioned yet that okay, we start with the IoT in our Kubota farm to raise an awareness is that the cost is not high and we can experiment about that. And I have also started another project about the AI machine learning to forecasting the or predict the repurchase customers. We have to do the like two approach at once. One project is totally about technology. It's like the IoT, the sensor, the data integration. Another project is totally about the business. Try to focus about the benefit of the business, like in this case, the repurchasing prediction of our customer, which is a totally amazed the management and also lots of staff that the prediction model based on AI machine learning has a very high precise rate compared to the rule base of the or the rule that implies from the knowledge of the people is very have a very precise compared to in the past. So we approach to project at once to alert all the stakeholder, especially the management, to aware and understand that we can do it cheap and effective, and also have a very high result compared to their business and very cheap cost in terms of the technologies. So we are now in process of raising the awareness and it's like raising the fund from the management to give us the resource, the manpowers, the money to develop more. But so for implementing AI and the machine learning technology, I guess the key is that you have to firstly to get the attention by propose the benefit that directly impact the business, and also propose another small project to explore about the technologies, because the first one will be about the maybe not sophisticated technology, not new technology at all, that already work and already prove that it works. So you propose to the management, and you have to have another very small one to explore the newest trend or the newest technology available in the market or even in research. So go parallel and then try to get attention from the stakeholder all the time, that you are moving forward and slowly transform and getting more attention and more participant to test and to involve on those projects repeatedly. I guess that's a way to move the corporate moving forward to AI and the digital transformation. Yeah.
Okay, we're running out of time, but just one last question.
Okay.
Is there any rule-based implementation in addition to machine learning?
Yes. Frankly speaking, yes. In practical way, the machine learning concept is not the holy grail of any solution. Rule-based is more easier in some case, and most of the case, maybe rule-based is enough. Like For example, in the intelligent vehicle solution, maybe current trend is that, oh, okay, we have to do deep learning, we have to do machine learning. But in my practice or in my project that we implement or we tested, we can do machine learning or deep learning in fragment and then synergizing together based on the rule base. Maybe it's much faster to develop because if we broken down the technology into fragment, we can get the ready to made solution in the market. Like for example, the traffic sign detection. You can get any models on the internet for free. You do no need to develop anything. There are already lots of research and lots of developers that share their models and their solution on the GitHub or any mediums article. So you can get that for free. And then you synergize those together with just a rule base, or if you are so fun with the machine learning, you can use machine learning to integrate that solution. It will be much simpler and much faster to go to the market instead of using the totally AI based or machine learning based on those solutions. So in my answer is that you have to synergize all your knowledge. The old technologies is not bad. It applicable and optimal in most cases, but some case is not. So you can use newer technology to enhance the old solution to be more advanced and more efficient. I guess that's the best solution to implement to any newest transformation of technology nowadays. Yeah, thank you very much.
Thank you again, Kunmeti.
Hi.
Now let us welcome our next expert, Professor Witaya Wanasupopasit, the President of Thai Robotics Society and the Director of International School of Engineering at Chulalongkorn University. Professor Witaya has led several projects with industries such as Robotics and Human Augmentation Program, New Paradigm in Advanced Robotics Manufacturing, development of novel evaluation system for vehicle dynamics, driving and components, and many, many more. We warmly welcome Professor Witaya for his presentation on cobots, collaborative robots, and intelligent assist device from laboratories to real application. Welcome, sir.
Okay, thank you. Sawasdee krap. Well, thank you very much for the kind introductions. And also, greeting, good morning, I think, to our professor and also all participants in this tech talk. Okay, well, before I continue, actually, I was invited to come. Let me show my screen real quick. Okay, hold on. Is it coming okay?
Yes, sir. We can see your presentation.
Thank you. Okay. What I'm going today, I'm not going to come and talk in the more technicals, but rather I would focus on the topics. Okay, that how could we come up with the advanced robotics? Okay, from laboratory to real applications, and also by chance, okay, have been in that process since we solve the basic problem until we have a very nice, excellent ideas, and we pursue that, okay, to the big research, and from there, okay, we use our research to do the industrial prototype and expand more, okay, to the application in the automotive industry, in robotics, and also in material handling worlds, okay. And I would like to share this with you. Okay, so again, I'm not going to present my recent research, okay, but rather to share how this thing be able to come, okay, and I think it's worthwhile, okay, kind of share the story that have been from 0 to 10, okay, what's going on. Okay, maybe related to my talk, okay, I actually built the first cobot, okay, in the world. Okay, together with the professor from Northwestern University, okay, when I was a PhD student, okay, And from there, we also expand our idea and our research to do the industrial cobot or collaborative robot, okay, for General Motors and for Ford Motor Company in United States. We also found companies named Robotics, okay, that actually trying to convey our laboratory research, okay, to the industrial prototype and industrial products. And later we also invent the a device, intelligent assist device, especially we call iToys, okay, which is I'm going to provide you in more details, okay, how things go and what the part they do coming, okay, and those companies already acquired by Stanley companies, okay, and the product right now still have been used and have been sold around the world. Okay. Related to this product, we also have 5 patents related to it, okay, and currently I'm taking managing roles on the director of the International School of Engineering, Chulalongkorn University, and also the president of Thai Robotics Society. Okay. This content I would like to cover. Okay. Well, of course, the theme of the tech talk is about the laboratory to application. I would like to change the theme a little bit. Okay, I would like to change the instead of in addition from laboratory to application. What about from problem to products? Okay, I would like to refresh myself backward. Okay, like back to the past and back to the future. Okay, to see that how could we come up with cobot, which is right now is the a device or a robot that using a lot around the world. Okay, what is the original idea of this? Okay, and how could we come up with industrial cobots? Okay, and a case study about how we create the industrial or intelligent assist device. Okay, from the laboratory. Okay, to expand, to be more detailed, and then expand it to industrial cobot and to the intelligent assist device. Okay, and if the time allows, okay, depends. Okay, I also can share with you guys about the with the same methodology. Okay, same methodology that we have been learned how to develop the research, okay, to a commercial products. We also use that similar procedures to apply for the Thailand situation last year. Last year, we even like now, okay, we have a lot of problem with the COVID-19. We have a limited resource on the doctor hospitals, okay, and we need to come up with the a technology, especially a robot technology that be able to help assist doctor in the hospital around Thailand and be able to do it successfully. Be able to send the more than 200 Pinto robots or delivery robot, okay, to 140 hospitals around Thailand. And if I finish the first part, I will also cover the second part as well. Okay. We start with a problem. Okay. Long time ago, I think we have a robot since I was born. You guys too, I think. When we were born, okay, we saw a robot. And an industrial robot basically is a very very industrial task device. Okay, it's a programmable device that helping you to do a lot of work, heavy work, dangerous work. Okay, however, it's still very powerful and can do very precise work. But industrial robot was designed originally, okay, to do a standalone work. Okay, General Motors, okay, at United States, at Warren, Michigan, contact us and would like to ask us to come up with a technology that can combine the robot advantage with human operators. They would like to combine the ability of human. That's so good. Okay, even I close my eye, and you'll be able to catch a lot of things. Okay, we have a lot of sense of touch. We can do a lot of complicated work without adding any cost. But human are free, right? Compared to robot, if you design a robot to have a certificate system, you have to require a lot of sensor, require a lot of redundant safety. Okay, but since they are not kind of the robot yet. So the cobot haven't born yet. Okay, so we are the first one that solve this problem, and the need. Okay, there's a need to ask us to how could we come up with the a way that can combine the robot and human to work together. For example, carry an object, okay, heavy object, and can assemble to a car. These are tasks that we have been got from the General Motors. Okay, so what we do, we are a researcher, okay, working on the haptic interface. Haptic interface is a research area that cover human, robot, machine interaction. So we understand about how human interact with robot, how human interact with machine, how safely, what the boundary that could do that. Okay, we realize so, and we try to see what the original idea that we can come up with and can solve this problem. Well, I would like to give you some example. Okay, on my right hand here. Okay, if you have a Cartesian robot, okay, very simple Cartesian robot. Imagine that human operator have to carry a weight, a very big weight, like their own weight, about 100 kilograms. Okay, and have to manipulate it with the speed about 2 meters per second. Okay, in a circular motion like this. If we use the existing technology like a gantry or Cartesian robot to do so, we need at least about 2 kilowatt power of motors, okay, of a system, okay, in order to be able to control a device, be able to control an object that have 100 kilograms to move around a circle of 30 centimeters with 2 meters per second. It's a lot of power. Think about if you or myself have to grab this object and work with a robot that have a 2 kilowatt power on it. They have potentially dangerous to you, right? Because it's too massive. And most of robots are actually they are not back drivable. They have a lot of gear, transmission, okay, that basically not back drivable and really heavy. Okay, so it's potentially dangerous when we interact with those kind of high power robot. And how could we going to do it safely then? We also need robot, right? We also need a robot. We need to design a thing that be able to work with human. So what we do, we investigate the how human operator manipulate an object. Think about the 2D space first. Think about in planar space. Okay, like this on your right side. Okay, think about this. If human have to push along the heavy object, okay, along a part, okay, what involve, what power, what effort that human need to supply in order to manipulate the object? We found two things. First, along the path of motion, I think human need to provide a change in momentum or a change in velocity. Okay, and we found that this is pretty simple and not require too many power at all. Think about yourself. Okay, think about a lady. Okay, even be a small man, even myself. Okay, I consider to be a small man. Okay, we be able to push a heavy car like almost 1,000 kilograms easily. Right, we can push it, so a car will be able to move. Okay, but we also found that in addition, for human to manipulate object along the path that need to change momentum, which is we can do not too bad on those. The bad part is human need to provide a big effort to change their direction though. It's a huge thing. Okay, so to change direction of an object, you require a lot of power, similar to this Cartesian robot. You can see that this object, okay, is rotated by the gantry robot at the circular motion, okay, at the same speed, but they require a big power to change their direction with the same speed. We not change momentum at all. Okay, so how can we come up with it? We use a lot of brainstorming. We use a lot of things. We even create a lot of things, and we come up with this. with this idea. Okay, so we're thinking about what human actually help, what additional thing that human could use, okay, in real life when they manipulate an object. So what they do, okay, we're thinking about the something like a real guidance, a physical guidance. If you have to manipulate a small object or heavy object along the guidance, you can do it pretty easily. Pretty easy. By the concept, okay, we come up with the thing that we call non-holonomic haptic display. We already use a simple device called a wheel. Again, we're not reinventing the wheel, rather we're using it. Okay, the wheel is basically a CVT, continuous variable transmission. Okay, that we use a steering motor as a wheel. Okay, and we equip the steering motor with the state wheels on the Cartesian device like this. Okay, and we build a prototype. Okay, here. Okay, and in fact, with a very simple steerable device like this, we able to assist a human, okay, to perform a job or to manipulate object really easily with only 10 watt of power compared to the 3 kilowatt. Okay, we can do the very small steerable power, okay, that assists human operator to perform a job nicely. Okay, and you know, this is the my first paper in my life that I submit to the one of the biggest conference in the world in robotics. It's IEEE. I think you probably know about this conference. It's ICRA, International Conference on Robotics and Automation, IEEE. Okay, so I submit this. Okay, and interesting. I got about 3 to 4 comments from the reviewers. Three of them is really say that, wow, it's a wonderful idea. This is nice. Okay, how could you come up with this idea? But one idea really discouraged me. Okay, the comment is so short. Okay, they said that, what are you doing? This is a step backward on robotics. That was the comment on my work. Okay. And together with my advisor, we really discouraged. And he said, wow, how could you think about this? Okay. Okay, we still continue to submit our paper. And what it turned out, okay, almost 1,000 paper that accept to the conference, our paper, non-holonomic haptic display, okay, which use the programmable constraint passively, okay, we won and we got the best paper award. The one of the biggest award on a conference. Okay, so it had been proved that we go to the right way, and the community accept the right thing. Okay, and said that this is the really the big step. Okay, in robotics, and that is origin of cobot. I also have the first cobot in my hand. This is the first cobot. Okay. That's the first one. This is the first cobot of the world. It's in my hand here. Okay, so and the one that we presented in this paper. Okay, and from there, okay, from the very simple device that only can do 2 degrees of freedom assist device, we expand a lot. Okay, we expand to do the 3 degrees of freedoms with the with additional degree of freedom. We also do the manipulators. Instead of the planar motion device like a robot, like a scooter or unicycle robot, a cobot, we also do the a pantograph, okay, and and also 3D manipulator cobots, a power cobot to be able to assist power as well, and okay, we also do the expanding a cobot that be able to reconfigure itself when they go into the small space, and can expand itself when you go out to the bigger space. We do a lot of things, okay, from the laboratories. We produce a lot of paper about this, okay. The paper mostly, okay, from Chulalongkorn University, Northwestern University, some from National University of Singapore, okay, and some from University of Florida, okay. We have a lot of peers in cobots, okay, that develop a lot of cobot in that moment, okay. And what we I myself, okay, really proud, okay. If you are the old people, you must know this magazine, okay, we call it Popular Mechanics magazine. I also features on that magazine as well. Okay, this is my myself. Okay, on the my second prototype of cobot. Okay, and we got award as well. Actually, we got nominee to the Discovery Award at United States. We are the finalists. We not won the award. We are the finalists. Okay, and also we think quite promising. We develop a good a lot of prototype that really promising from laboratories. Okay, and it's time to expand our ideas, and we got a lot of support. This is the first industrial cobot that we developed for General Motors. Okay, what it does, okay, it's a robot. It's platform that a scooter robot, okay, that basically attached with a robotic device, okay, manipulators that what they do is they're basically guiding human operator, okay, to the vehicle and remove the door. It's a first process, okay. When you assemble the doors, usually they have to paint the door, the whole. They have to sink all the door, all the bodies, all the car to the paint, and once they get the paint that is coming out, the first process they have to remove the door out in order to put a part inside. Okay, and remove the door is really hard to do because you have two hinges. Okay, you have to very precise to lift the thing off. Very precise. We're talking about the very small millimeters, about 1 millimeter precision, less than that, in order to take this thing off. Okay, so we develop a cobot so human operator can perform this job. Okay, nicely. Okay, and they wonderfully perform. I have video later you can see. Okay, and we also developed a second prototype industrial cobot for the Ford, okay, companies at Dearborn in Michigan as well. But this one for different purpose to carry a bumpers. Okay, and I also write my paper after my graduate. The paper is about the material handling using the cobot. I also won the best paper as well. Okay. Maybe let me show you the videos of what's the industrial cobot look like. Okay, maybe here, maybe let I stop chatting first. Let I share my video. Where it is? Oh, here we go. Can you guys see the video?
Yes, sir.
Thank you.
It is a timeless image that reflects an age-old fascination, the abilities and capabilities of the human mind and body. Long before this image was created, and now more than ever, the study has continued. The body, how does it do what it can do? By extension, what tools can be designed to assist in work and improve performance? There is certainly no greater example of the application of the results of this research than the manufacturing process. Newer images, these less than 60 years old, illustrate current progress by their own amazingly dated appearance. Automation progresses, physical assistance is limited, and humans, with cognitive ability unequaled and sensory perception unmatched, remain the critical components. Today, familiar images of the advanced levels of automation and robotics reflect the current state of automotive manufacturing. The body shop, a seemingly choreographed showcase of production technology, unprecedented levels of automation, speed, efficiency. The paint shop, formerly a less safe domain of man, is now a cleaner, safer, more efficient environment offering consistent quality and predictable performance. The body shop and paint shop have been changed forever with the implementation of massive robots and exploitation of robotic attributes, strength, consistency, and tireless efficiency beyond any human ability. But what about general assembly, where subsystems come together in the final stage of automotive production? Humans have played and will continue to play the most important role in this, the most intricate part of the manufacturing process. Here, workers need to rely on experience and sight and touch. Decisions and adjustments are made quickly and constantly. The right part for the right model, the speed of the line, placement of the part. The ability of a worker to sense, process, and adapt is obvious and impressive. This worker, Don Bowman, is actually nearly blind, but can rely on other heightened senses and experience, and has adapted to meet the requirements of the task. All of this underscores the need for a tool that not only lightens the worker's physical requirements of lifting or holding, but also provides task-dependent guidance. That is, it underscores the need for intelligent assists. General assembly requires human involvement, yet these humans have physical limitations. According to the U.S. Department of Labor, overexertion while maneuvering objects led all other disabling events or exposures. This ergonomic liability is, in fact, cited in up to 1/3 of all cases in manufacturing environments. So the challenge is to assist the indispensable worker. Help to limit the lifting, bending, and contorting while also avoiding the safety hazards of massive, powerful robots. The assist for these general assembly tasks must satisfy ergonomic requirements while maintaining a level of performance that must be equal to or greater than that already in place. The assist tools must improve the worker's ability to prepare, position, and place parts and assemblies while providing consistent and reliable yet simple and safe assistance with repetitive tasks. A worker in this situation must bring in a cockpit subassembly through a limited opening, the door. The assembly must then be oriented, fit, and fastened. A human will encounter ergonomic difficulties with the task, and a robot alone could not accomplish the fine adjustments necessary. The General Motors Robotics and General Assembly Center, Northwestern University, combines intelligent robotic assistance with human force and perceptory senses. This is Scooter, a prototype cobot developed by Northwestern University graduate student and General Motors intern Vitaya Wanasupoprasad. The worker provides the force to move the cobot and its load. The worker is essentially coupled to the passive device through his efforts to move the load. The cobot offers assistance in moving the load, but more importantly, through a software-driven process, it helps the worker guide the load to its final resting spot. Invisible or virtual walls are programmed in. The cobot allows movement only within and along those walls. The wheels simply pivot and redirect worker energy along the invisible virtual walls. There are no brakes on this unit. The programming still allows for the worker to see or feel adjustments needed and provide the force necessary to modify the path of the load. Building on the promise of Scooter, the GM Northwestern team designed and built the world's first industrial cobot, a full-scale prototype cobot-based door unloader for the Pontiac Grand Am. The doors-off process, the first task.
You just saw that it actually takes only 1 second, okay, for this human operator to remove the door off. Okay, so fast, okay, and really easy. So they kind of effort said, push the the cobot through the door, and then once they engage it, they can lift it up immediately. Okay, it's so quick. Okay.
In the GA bill of process requires the removal of the painted door from the painted body shell in order to simplify the remaining GA assembly tasks. The doors-off tool has two primary components, a scooter-like computer-assisted cobotic base and a non-traditional door removal tool. The cobotic base consists of an integrating platform, a steering handle, 3-wheel units, a computer, and some sensing to precisely locate the platform with respect to the vehicle body. Note that the wheels rotate in response to the handle motion in the caster mode. The door removal tool consists of the lift unit. The door unloader, like Scooter, demonstrates all the basic cobotic control modes. For example, the door unloader can enforce a circular trajectory on the operator. The doors-off process essentially requires the operator to position him or herself with respect to the vehicle on the moving line. The precise location sensing and control methods enabled by cobots ensure that the operator is positioned in all 3 degrees of freedom, X, Y, and theta. Once positioned, he or she activates the 2-stage lift mechanism, which lifts the door in an imprecise mode, followed by a very precise mode. At the instant that the door is taken off the vehicle, the cobot executes an escape trajectory that, for quality purposes, clears the door and the unloader from the vicinity of any Class A surfaces on the vehicle.
This is important because a very tight tolerance. Okay, if any mistake, okay, the paint will be catch. Okay, and is some damage on the car.
The operator then drives the unit toward the drop-off station, where the door is carried away to the door trim area for installation of equipment like the glass and window regulator. The door unloader and its predecessors highlight the original goals of the project: to provide the assembly line worker with state-of-the-art assist tools, the ability to mitigate ergonomic problems by providing large, easy-to-hit gross targets, and the potential to impact productivity. These cobotic devices are intrinsically safe. There are no unsafe, powerful motors. Without these motors, the cobots themselves appear less bulky and unwieldy to the operator. Finally, as the system is software-driven, it is flexible and adaptive. Research continues to develop the intelligent assist concept further. And while GM won't be producing these intelligent assist devices, GM is working with suppliers to develop and produce intelligent assists that ensure operator safety while facilitating the performance of the operator's task.
This video after this shortly about the overrails, okay, overhead robot. This is the one that carry the bumper at Ford airborne, okay, so that they can, precisely locate the bumper on the jig. Actually, on the opposite side, okay, and human operator doesn't have to do anything. Yeah. So, let I come back to my presentation. Okay. Well, that for the pure passive cobot. Okay. So I just show you the past that how could we come up with the problems, okay, to the ideas, to the development in laboratories, okay, and to deliver application on the automotive industry like General Motors and Ford. We not only stop like that, okay. Okay, as a researcher, okay, you might be fulfilled some complicated work, but we do something further. Okay, we investigate more. Okay, and we found once we get into real problems, I'm going to show you later what it is. Okay, now we're going to move toward to the another domain that we call the intelligent assist device. Like I mentioned earlier, when human actually operate an object, okay, in addition to changing momentum along the path and need a lot of power to change in direction, which is recovered by cobot, okay, there's also a need to change in height. And basically, people still need to lift, object against the gravities. How could we come up with the assist device that we have to cover all 3 areas: changing momentum, changing direction, and changing height? Or any concept that we can use so people can basically manipulate object with the anti-gravity device or some kind of things. Okay. Again, we start with a problem. Okay, I would like to share you the case study that how could we develop the industrial intelligent assist device in automotive industry. Okay. Start with the problem. Wow. Okay, the same company, not only GM, but the whole industry, on the automobile industry. This is what they found. They found that 43%, okay, of the worker has some injury. And they found that the injury actually happened because of the reaction and exertion. And 62% of this illness caused by the repeated trauma disorder. Okay, and it caused a lot of problem because 1/3 of 32% of the day went away of the worker is actually result from the this kind of problems, and it costs a lot of money. Okay, because the company need to pay for their welfare to treat them, and also to find a way, find additional people to help to do to solve this problem. They had to lose a lot of money, big chunk of money, about almost 20 billions US dollar yearly to solve this kind, to have to compensate for this kind of problems. Okay, so we working on the industrial cobot, and we also working on this problem at the same time. We also found that the problem occur when human operator, assembly object in a car. And basically, when human operator carry a big object and manipulate a heavy and bulky object, because human need to provide high effort to carry and move, and think about ourselves. If you need to lift the heavy thing, couple times a day, to fine. But operators, worker, they need to do that 8 times a day. Sorry, 8 hours a day. They need to do that all the time, and that causes the thing that we call trauma disorder. Okay, and it's difficult to replace the worker and human because it's require a trained personnel. Okay, and require the trained person in order to perform a task, specific task. Okay, and we investigate what device are they using at that moment. Okay, we found they're using electric hoist, balancer, counterbalance, and they still have those kind of problems. Okay, so they're using this kind of thing too. They use the electric hoist, which is basically too slow, okay, and very difficult to manipulate an object, because when you need to lift something up, you need to push one hand to grab on the handle and to push a button to move the object up, move the object down. So you lose one hand already, and you have only another hand to carry object. Okay, that's kind of not convenience and slow. And we found the material handling industry use a lot of this device. This device called pneumatic balancer. So they use the application of the pneumatics, high the pressure to convert to rotational to rotate the drum to move the object up and down. This is really fast. They love free device. Okay, I also play with this thing a lot. Okay, it's fast, it's cheaper than more than electrics. Okay, however, you still need one hand to operate it. Okay, the button up and down. Even you can integrate the button to the device. You can do that. Okay, even though they still have some problem when you move things fast. It's pretty hard to control the pneumatic device to have the not overshoot or undershoot. Okay, so it all have some problem as well. And in fact, it's also pretty heavy. Okay, it's still heavy. Okay, so these are new class of device. Okay, that they need an intelligent assistive way to lift an object, and those things have to be light and small, and have to move very fast as well. How fast it is? Think about your hand. Think about your hand. When you move your hand, manipulate object, those kind of fasting, it should be fast, and it should be move along human motion so that they not, restrict human motion when they move. And in fact, we prefer that humans should be manipulated directly to an object. Okay, how could we do that? Okay, with our technologies since then, way back ago. Okay, so what we do, we develop a really simple robot we call intelligent lift. Okay, so it's a greater response. Okay, it's have the performance matching human motion, intelligence, it's programmable. Okay, and also can move along human operator and have a programmable profile. It basically high performance electric hoist with the programmable, with the robotic technology that enclosed in the system. Okay, So, and we also develop a new handles. Okay, we call inline handles. Actually, this is not the up and down handle. We call intent handle that lead human intention, what human would like to do, and try to act, according to human intention. Okay, so develop this human. We develop this new handle. Okay, it's with control device directly. This can match human motion and can control object directly. Okay, with two hands. So this is the overall system. This is my design that I make that a long time ago. Okay, and we also build a prototype. Okay, and the handle prototype as well. Okay, so we're successfully building it. Okay, and this overall thing, what it look like. It just look like the thing from a machine shop, of course. Okay, so we engineer over duty try to make things work, and this work nicely. Okay, work wonderfully. Okay, so I show you how it works. Okay, we test those things in the over garage. Okay, and in a small workshop. Okay, this is the device. Can see how fast a human can move. And right now they
and the machine right now with a lot lighter load, 60 sound load.
With different rating, you can do the same thing. We already meet the requirement that light and small and can move fast, can move really fast and really stable. All the position is really nice control. It looks like we move the object effortlessly, effortlessly. Okay. However, we still need overhand, okay, to put on the handle. Okay, we would like to go beyond that. Okay, how could we, directly manipulate an object? Okay, this video we answer this. Hold on, I'm sorry, I made a little mistake. Oh, for some reason I don't have those video. Maybe I can show you from my screen then. I'm sorry, I don't know what's going on. Just a second. Let me share my another screen just for this. Okay.
Is it in float mode?
You can see that. Right now, we can grab directly on the object and manipulate it. Very stable. When we change to the different weight, okay, you can perform the same thing with different weight. Really nice precision, and you can actually assemble a lot of things with this. Okay. All right. Maybe let I go back to my presentation. Okay, so we successfully developed the a prototype that be able to, help human operator to lift an object effortlessly. It's light and small, can move fast, can move along human motion, and also you can directly, grab on the object and manipulate it. Okay, very precise. Okay, so and we do addition. We also evaluate by putting on the real plant. We put our device side by side to the pneumatic balancer. Okay, and we also put the in the application as well. We put the real test. This one is assembly the propel shaft on the GM truck. Okay, they use this device. Okay, our eyelift to testing it, and this one they use it to move the Coca-Cola can. Okay, the big box that's pretty heavy, so reduce and help human operator to do some, moving material handling job. Okay, so we done a lot of the plant factory evaluation, and it turned out really nicely. Okay, so and we patent our ideas. I am the main inventors of the intelligent lift. We patent it. Okay, and when we get everything covers, okay, the patents, what next we do as an engineer, and also would like to recommend all you guys to do. We're not expert to make things nice though. I myself have to work with the design company, okay, to make this product look nice like this. Okay, we work with a company, okay, in the Chicago areas, ask them to redesign our product to the real commercial products. Okay, you can see that they change a lot of my design there. Okay, and put a lot of nice, cover, nice design, a lot of thing there. Okay, and since then we already found our company named Robotics, okay, corporation. So we developed the industrial cobot and also developed industrial intelligent assisted right, okay, and several product around the United States. Okay. The whole system is like this. Whole system is basically you can have the eye lift that carry the object up and down, and we also have the system that be able to assist human to move around and to increase their change in momentum as well. Okay, so it's kind of nice to have this kind of the system. Okay, can do a virtual surface, virtual limit, and also developable on the cable ankle sensor that detect human motion where they want to go. Okay, and in fact, later our companies have been acquired by Stanley company, and right now the product belong to Stanley. Okay, Stanley companies. You can search on the internet. Okay, Stanley Robotics. You can this thing gonna coming up. Okay, so and Stanley actually sell robotics, eye lift, and eye tourists around the world. Okay, they sell it around the world. These products have been sold and using not only in the automotive industry, but using in a different kind of material handling industry. Okay, it's funny. I also found my work in Korean, if I'm right, in the Korean language. Okay, and this one have been translated. Okay, my manual and all the things have been translated in the Korean market. Okay, this also selling in Korean market as well. Okay, so and this is the story right to share with you guys. Okay, that how could everything basically come up with the from from the laboratory to application. Okay, which is I would like to emphasize that how could we as a researcher and developer, okay, whatever you say, okay, would like to share that a little bit. Okay, how could we change from problems to products? Okay, I list some of the key things that I found personally. Okay, I would like to capture, and hopefully that this page would contribute to some of you guys. Okay, when you think about as a researcher, you guys are right now, how could we going to do the real thing for the real application? Okay, at first, okay, most of the time, a researcher like you guys and myself too would like to pursue our dream. If we're good at robotics, we're gonna go for robotic field, right? We're good at the if I graduate from special topic, right, to pursue the topic. Okay, myself would like to thinking like this. Okay, do not start with those. If you would like to go for the application, you have to start with real demands. It's a must. Start with real demand. At first, we got real demand from General Motors and Ford and from automotive industry. The whole industry needed. We start with those. Okay, and second, okay, most of the time we're going to find technology like a literature reviews, right? We can find, hey, let's think about what technology available that we can apply to these problems, what control algorithms, that we can use and be able to solve this problem, you can do that. Okay. However, what have we found and really pay key roles in here? Okay, we need to truly understand the problem first. And what we done, we not apply technology to it, but we try to understand it, what the problem, what the root cause of problem, and we decompose the problem into the fundamental level. Like we decompose um, the object manipulators into three areas: change in momentum, change in direction, and change in height. Okay, we decompose it, and with those decomposition, we're going to see that what available, what fundamentals thing, and what technology, even new ones or the old ones that can apply, can use it. The idea is so important. Focus a lot more on how could you solve the fundamental level problems. Okay, and we work a lot. Okay, start our work from fundamental level, like we start from very simple device like this. This is the first cobot in the world. We started very simple one-wheel device. Okay, and then we expand it. When we understand everything nicely, we expand it to a general framework, to the energy freedoms, to the power cobot. Okay, and then we also use the simplest solution to solve the main problem. Okay, and last but not least, we test our evaluation in the real environment. Okay, so I think I probably wouldn't be able to cover my second topic about the CEO about COVID. I saw the time is about 11:50 already. I probably would ask the host that if you allow me for 5 minutes, I will cover for it. Okay. If not, we can ask for the question. It's up to you guys.
Sure, Professor Vitaya, you can go on, sir.
Oh, okay. All right. Well, okay. Since I can show real quick the with the same principle and also matching the hold on. Okay, is that my slides coming?
Yes, sir.
Okay.
Yes.
All right, I'm gonna go this through real quick. Okay, I'd like to share with you guys the same principle that I just concluded that I use all the time. We, as the Thai engineer like you guys, or engineer like you guys, okay, thinking about during a COVID situation, as a robotic researcher, how could we help our country? How could we help hospitals that already need help to cope with the COVID situation? And if you remember, at this time last year, we have to have a curfew in Thailand. Nobody can go out, okay, after 8 p.m. And all the supply chain have been stopped around the world. You cannot purchase anything at all. And even though with those situations, how could we come up with things that could help people, that could help doctors around Thailand? Okay, so I would like to share you with the success story that we'll be able to deploy a robot, okay, to 140 hospitals around Thailand to assist a robot in a COVID-19 situation with a limited resource, with limited time. Okay, so really share with you how we do it. Okay, like you guys know, in this situation, we use a lot of, we have faced a lot of problem. PPE is very limited. Okay, and also a lot of country, do not send any medical device outside because they also want it. Around the world, they have own problems. As Thailand, we don't produce our own robot. Okay, but we have a lot of robot researchers. How can we help? Okay, so we found a team. Okay, in Chulalongkorn University, we found a team. Okay, so a team from myself. I'm the head of the team. My dean asked me to be the head of the team of the CEO for COVID, and we work with the startup company of our own alumni. Okay, two companies. The first one is a high cloud company, and second one is it's an Overdose company, and we work with a rest of people as well. Right? How could we deploy hundreds of robots to help hospital in really short time in COVID situation? We're not talking about one or two robots. We're talking about hundreds of robots. How can we do it? Okay, so we use the same platform like I mentioned before. Okay, we have to find the factory requirement that what the hospital really needed. Okay, and we do a quick prototype, we deploy, we checking, and then we revise all the prototype, and finally we able to produce the robot and distribute to the hospital around Thailand on time. Okay, so what we do, okay, this is a key thing. Most of the time, what we done, we're gonna provide what we thinking is the best for hospital and give it to them, right? But this time we do something different. We not do anything yet, but we send our team. Okay, our team went to hospital, stay with a doctor, and see how he treat or how he take care COVID patient, and investigate it. Talk with doctor for several hospital, go and see by themselves. Okay, what they need and what they requirement, and we come up with two things. Okay, first, okay, after we going there, we know that people, doctor need a delivery robot, a robot that can, send stuff, send medicine, send food, send something to patient remotely. They want that, and don't have to be automatic system. There got to be something that you can send remotely. And second, they need communication system, like line call, things like this, like FaceTime, but something better. They need two things that we found. So we come back, okay, at the our facilities, okay, in the Chulalongkorn University, and we noticed that in the hospitals, there's limited space. They put a lot of space, and they put the the patient along, okay, and we found that they have some device already like this. They also have some a card, a food card or medical card, musical card like this. They already have this, and they're using those. So we think about how can we modify this standard card, food card, to be a robotic device that can send a medicine, send a food to patient, and we mock up this system within a day. Okay, we create this in a day, and we send those video to the doctor, and doctor said, "Hey, yeah, I want this kind of device. Just go ahead and send to try." So we do it. Okay, we make this thing, and we go to the hospital. It's in that time. We went to the Thammasat, Chakri Narubadin. We sent to Chulalongkorn Hospital, Pamongkut Hospital, Ramang Hospital. We sent to those, and we test it. We even leave our robot for 2 or 3 days, okay, and come back. And in fact, okay, one day on the 29th of March last year, we delivered our first prototype. We bring prototype to the Lama Tipudi Hospital, testing out. But it turned out they asked us, can I have the robot right now? Because they need to open the COVID ward tomorrow. Okay, and it turned out we have to give our first prototype, okay, Lama Tipudi Hospital on the March. Okay, and after those, okay, I actually tell you, we not only develop the delivery robot or Pinto robot that we call later, we also develop the telemedicine system, okay, or Krachok, a Miller system that be able to communicate with patient directly. Okay, so, and this is two products, okay, Pinto robot and telemedicine system that we create, 100, 200 of Pinto robot, and almost 1,000 television system, and deliver those to the hospital around Thailand. Okay, I think that pretty much. We have a lot of video, and I probably wouldn't be able to cover those at time. Okay, we also very fortunate that the Princess Mahachakri also donate a seeding fund to us. Okay, to build this robot as well. Okay, and we send a lot of robot outside. Okay, And in fact, I like to show this guy, this thing to you. This is the video that we send the robot to Bhumipon Hospital. When we give it to them, they use it immediately. Okay, they actually command the Pinto robot to a patient and gather some sample from patient without going inside. Of course, it is a very simple robot that remote control, but it's the simplest thing that operator who haven't used robot before be able to use it only 5 minutes after they grab the control. It's the first time that they grab the robot. And we use this similar device to send to a lot of things. And in fact, it's really nice and it's works nicely. It is at the Common Hospital. It's not only robot, it's a lot beyond. What you see there, a nurse basically noticed that this COVID patient have a birthday. So they give a birthday present and sing a birthday song to a COVID patient inside the ward. They cannot go inside. Okay, so it's a lot of good devices. But, you find the right way. To find the right way to solve the problem. You can do it. Sorry, let me share with you guys that how could we solve those people on time on the video. Okay, so I think I probably conclude my talk right here. Okay, and I think I probably take a whole 1 hour, and also would like to cover what we be able to share to you guys that from research of the laboratory to the application and from problem to products. Okay, so thank you.
Thank you very much, Professor Vitaya, for inspiring us with your highly informative presentation. Do we have any question from the audience? I think everyone is hungry now.
I think so.
Please don't leave yet. We still have more presentations in the afternoon, but for now, it's time to take our lunch break for an hour. Thank you again to all our speakers for taking time to be part of our AA Tech Talk today. Much appreciate. And okay, let's have our lunch break now. See you in an hour. Thank you all for joining us.
Okay, thank you.